Hello and welcome to the Cemtech webinar. It's great to be back in the UK after our trip out to Riyadh. My name's Thomas Armstrong. I'm Managing Editor of International Cement Review, and it's a pleasure to host again this monthly webinar. Here's the schedule for the year, and we're already on to the second month. If you haven't been to our webinars before, then I think you're in for a treat. We have excellent speakers and some time to really go deep into a topic. And today it's going to be digitalization. And now on to our discussions for today. I won't take too much time. We can get straight onto the presentations. There's a lot to get through, but really excited to be able to have such excellent companies here today to share their cutting edge technologies. Digitalization is more than ever at the heart of cement plants in every aspect. We're going to hear how it's helping in logistics, how it's helping bringing costs down, energy costs down, for forecasting, for real-time optimization. Really, it's quite amazing how many areas are now being improved, optimized in our sector. And we're going to start now with Fuller Technologies, of course, previously known as FL Schmidt. And I'm delighted to welcome our first speaker, Dinesh Sampath. Dinesh brings nearly 2 decades of global experience spanning cement process engineering, advanced process control, and digital transformation. During his career at FLS, now Fuller, he's held diverse roles across process design, field services, and APC delivery, combining deep technical expertise with commercial and strategic leadership. Today, Dinesh serves as Global Product Manager for ECS, ProcessExpert, Fuller's flagship APC platform, where he sets the product direction and roadmap, strengthening digital optimization. I think it's going to be a great way to start our session. Dinesh, if you'd like to share your slides, and the floor is yours.
Thank you, Thomas. Thank you very much for such a nice introduction. Hi all. I thank you for joining. I really welcome you for this session. Today I will take you through the ECS process expert in terms of the evolution, being it an industry benchmark for the advanced process control, and then how we try to add and enhance the optimization layer, adding the AI-based Softsensors to the ECS process expert. So we will see it in two important steps here. One, our self-adaptive controller, which is already delivering the best for the real-time optimization and forms as a new foundation. And then I'll jump into the partnership, which is the most exciting thing that we are doing now to enhance the capabilities of the optimization. So first, I'll take you through the evolution of the process expert, which we have which is rich in legacy over many decades. And then following that, we'll talk about the challenges in the advanced process control. I believe without addressing the challenges, I don't think we can have the right solution on the table. And into the self-adaptive control technology, what it has delivered to the market until now with the proven deployment across the worldwide. And finally, we'll finish about with the complementing the advancement in the partnership in terms of how the PXP is getting value added with the AI-based Softsensors through Imubit. First thing first, so here it starts with more than 40 years of legacy that we introduced PXP during 1980s as the first fuzzy control in the cement industry, transitioning into 1990s in the PC platform, and having a value creation with the version 7, which had the possibilities of model predictive controller, which is still being used in the advanced process control space during 2004. 2011 had been a big step in terms of delivering industry-specific object, meaning we made an application very tailor-made to the cement industry that built more confidence in the end users, especially the operator, that increased the transparency of using the application. So that got a lot of adoption and has been seen as one of the user-friendly application with the V8 version in 2011. So we always strive for implementing the latest technologies that can be, solving the real challenges that I will be speaking in the coming slides. And one of it, a big step change that we did was in 2024 with the version 9.1, where we introduced the self-adaptive control technology that is now seen as a industry leader in terms of advanced process control technologies. So now on to the challenges in the APC, advanced process control in cement manufacturing, specific to cement manufacturing. Not all the cement manufacturers really gets the full benefit of APC, and we need to understand why. Instrumentation and data reliability, any good, even a best advanced process control with all the the technology that it has to, should really need the base foundation is to have the right instrumentation and the reliable data to feed in. And then the process variability is something inevitable as we grow and mature in the industry, because we have different KPIs based on different regions which we need to satisfy. So that makes the process more non-linear. So the advanced process controller has to be more robust to take care of the process variability and non-linearity that comes along with the process. And then the most key thing is the adoption for the operator. If he thinks it's a black box, then he's going to override and kind of do a manual control. So the transparency and the trust makes the operator to utilize the advanced process control much in a longer sustainable way. And the other key aspect is about the ownership. So the lack of ownership is one of unfortunate situation. The success of the advanced process control is based on a mutual engagement where the supplier and also the cement manufacturers come together and not see advanced process control as a one-time project where we get that you deliver the benefits, maybe once you commission within 3 to 6 months and everybody is happy, and then we don't see it as a system in a long term where we have to set the KPIs, the relevant KPIs to periodically measure, and that creates an accountability to the end user. So that level of commitment and engagement is really required in a long-term success. And finally, the performance longevity. Any kind of a best APC will still have a degradation for various reasons. It could be process, it could be controller by itself, but we need to address this at the right time so we have the sustainable benefits in a longer duration. So all these parameters, all these challenges makes the success of the real, overcoming all these challenges makes the success of the real advanced process control technology. And we from Fuller in the ECS ProcessExpert try to focus on these challenges and provide solutions accordingly. And that is how we evolve our product and keep it very relevant to address the market. And that brings to the self-adaptive controller. So back in 2024, we would have shared about how we are introducing this new technology and so on. Now it is more about what it has delivered to the market with the global installation that we had. The self-adaptive controller, as it says, it can adjust to the changing process dynamics based on the rate predictive control technology. So it can self-learn. So it can predict the rate of change of the variable. By predicting the rate of change of the variable, it can act proactively. So since we are acting proactively, then it brings the stability in no time, avoiding the overshooting of the measurements or the variables, basically. So this increase in stability and kind of adaptive nature based on rate of prediction makes it outperform compared to a fixed model control technologies. When I say fixed model control technology, is more like MPCs and other old technologies with fuzzy and all. So this is a model-less controller, not any static model-based controller. So that delivers a sustainable benefits. And what makes it to stand out, makes it an outperforming controller in terms of the technology, or as I told, the stability, it increases the stability due by the nature of its design to adjust to the process dynamics. And then the most important aspect is with being a single whole controller. So the one single controller can handle the whole process, which means we don't have to really have multiple controllers tuned for multiple scenarios. We know the process has any operations has different scenarios, so we cannot wait for the scenario to happen so that we tune a controller for a normal conditions and upset conditions and the different conditions. So this is more intelligent and smart. That one controller can be smart enough to be aggressive and also to be sluggish or steady state, whatever it is required for the process. So we don't have to spend a lot of time tuning for the different conditions and deliver stable operations. So this leads to a path about high utilization. High utilization, if you ask me, that is the foundation for any justification on the KPIs. So we talk a lot about the benefits, we talk a lot about the improvements and so on, but it will be justified only we have a very high utilization. Even the enhancements that I'm going to talk about, adding a Softsensors to the layer and then trying to add more, trying to increase the optimization. Even for that, the foundation is high utilization. So we should have a high utilized advanced process control to add anything to that to improve it further. And this happens because the controller by nature can handle the constraints so very well that it is more flexible in handling the constraints, which can bring back an upset condition to a steady state, a stable condition in no time because of the repetitive actions. And then this leads, because of the superiority of the technology itself, we have a higher consistency and scalability in implementation, and then indirect way that we have a lower load in the system. So overall, I would say we could see from the last 1.5 years of our implementation that we saw a very robust control actions that made the utilization much higher, and that has become a benchmark in the industry now. So what we see in a standard APC and what this self-adaptive controller has enhanced, as you could see from on the KPIs, from a 2 to 5% of benefits in terms of energy consumption and the productivity, we could move to 4 to 7% of the benefits, and relative improvements in terms of CO2 and alternate fuel usage. Of course, these numbers will vary from plant to plant, but we must remember that the trend, what we are talking is the trend. The trend is proven that we could see that it can outperform a standard APC with a model-based control technology. And now coming to the benchmarking here. So the case stories. We had a real world case stories. I mean, in fact, we had more feedback and case stories from customers. Considering the time, I cannot present all of it. So we just picked 2 of these, which we already published in our forum in the web page. One of it is the GCC Mexico. Here it is an interesting story where the customer had to replace non-APC, non-PXP advanced process control to a PXP, looking at the technology that they were seeing it as a very positive thing, and then they could see the benefit, as you could see in the trend. In terms of capacity, as you could see, there's an improvement of about 4.2%, and also on the energy consumption, the power consumption, and heat consumption also as well. And the important thing is we could see there is an improvement in terms of the alternate fuel usage. That is one of the key things which we see in all of the plants that we implement, being a focus on the green fuel usage, and with also improvement in the product quality. Here it's being a kiln. It's a prelim standard deviation for the clinker. So this is one of, we could see the case stories already available in our web page. Another interesting story, this is one which we started, the customer which had much interest in, and being an early adopter. I'm talking back in 2024, where they were using our PXP 8.5, the version before the 9.1, for say 6 months to 1 year. But seeing the advancement of the technology, they wanted to upgrade to 9.1. So there you could see from the manual there was an improvement even with the 8.5, with the fixed model based standard APC approach. We had a benefit of about 3 to 4%, and then upgrading it to the 9.1 with the self adaptive control technology, there was another 3 to 4%, summing up it to around 7 to 8% of total benefit, and customer were very happy, as you could see from their acknowledgement that we received here. So this shows a clear difference of how a manual to a standard APC, and then from a standard to the self adaptive control technology here. So now, what have we delivered from July 2024 with the implementation on this, the controller, a strong controller that I've been explaining till now. So we have sold more than 140 applications now, and we have executed around 35 applications, over 35 applications now, for around 40 applications under execution, and we have plans for the 65 plus applications in the coming period. It could extend even 2027, of course. And you could see the split across the globe, worldwide implementation. And all of these 35 applications are running with a high utilization and a happy customer. So, yeah. So now we talked about a very strong foundation, a proven technology, and a controller that is robust. So while we have that, now we are which has addressed the major of the problems, challenges that I've been explaining. So now we have to turn into the other constraints, that is towards having the critical data on right time to enhance optimization. And for this reason, we have decided to we made a strategic partnership with Imubit. So what are we delivering here? So we are integrating the PXP 9.1 with the Imubit based, the AI based Softsensors from Imubit. We call it a best combination because fuller ECS ProcessExpert comes with a deep process knowledge and control knowledge over decades. And now we are adding it with Imubit, a robust platform with a high reliable and high accuracy Softsensors. And this combination makes it an optimal closed looping. With this optimal closed looping, we create a value to the end customer by filling the gaps in the spaces that is really required for the APC to enhance its optimization. So now, again, I'll go back to the challenges. I always like these challenges, so we understand what we are bringing and what we are solving here and how it is really helping to the end customer. So the current situation is we have an advanced process control with the quality data that is coming from the lab. Here we talk about specifically about Freelime C3S, Freelime or C3S for the kiln, and Blaine for the cement mill. And then also from the process side, we have inputs from kiln inlet oxygen, because the kiln inlet environment, we know environment is more harsh. I mean, in the sense it's very tough with sticky dust and also high temperature, which could lead to outages and maybe unavailability of the signals. So this is the present situation. But what happens because of this, we are left with blind spots. So basically we have limitations in the optimization. Even the best the technology, the best optimization engine that I explained will have the blind spots. So that we call it a lost opportunity, because it will be more reactive, that you have to wait for a lab signal, say for 2 hours, then you have to adjust the control actions, or you have to run a kiln probably for some period without a oxygen signal due to the maintenance issue. So what we do, we add the Softsensors from Imubit as a complementary solution to the PXP, both for example in the lab and for helping out on the clinker free-lime C3S or the blind in terms of quality or in terms of the kill inlet oxygen. And the outcome is we have a high frequent data, high frequent, high accurate and reliable prediction for the quality sensor free-lime C3S in the blind, and that gives a quick response to the process. So now the advanced process control has deeper insights of what is happening in the process based on the predictions coming from the AI-based soft sensors, and that can ensure that the actions are more proactive. So basically, we can adapt the target much frequently than to wait for a lab data which is 2 hours or even later, 4 hours or even further. So this makes it more proactive and kind of have the control actions well in advance. And for the cases like where we have an outage, maybe a less availability of oxygen due to other reasons, now we have a continuous data coming from the predictions, and that can really add an input to the process optimization, which can optimize the kill much better, improve the energy efficiency of the plant and the product quality as well. So from the limitation through by the blind spots of missing these critical data on the right time, we move towards a greater visibility where we have chances to maximize the opportunity. We reduce the gap and we maximize the opportunity space. Yeah. So this is the logical approach which makes a lot of sense, and in terms of enhancing the optimization with what we have now. And then we are now have to talk about the real experience that we had on site, where we did a trial in GCPV Monjos in Spain with a free-lime soft sensor integrated closed loop into PXP. And what we achieved, an improvement in the product quality in terms of reducing the off-spec clinker. That is a lot of improvement, and also improvement in energy efficiency. So we have a quick, it's a trend to show you the overview to understand how it was with the real-time experience on site. So the brown line, what you see is a predicted free-lime, which is at every 5 minutes interval. And then we have the lab free-lime, which is at 2 hours of interval. And then we have the torque target, which is now adapted every 15 minutes. So previously, assume without a prediction of free-lime, we have the target. So here the primary parameter to measure the kill process or the kill status is the torque of the kill. So it used to be adapted for the 2 hours based on the lab data. Now we are able to adapt based on 15 minutes, that is 8 times at least within the 2 hours based on the free-lime prediction. So if you see the accuracy and the directionality of the free-lime, we could see, for example, we could already sense that well in advance that we get a deeper insight that the product quality, what is the product quality that you're producing already in the kill. So by knowing that the product quality is changing continuously, we are also changing the target of the primary measurement. And because of that, the stability has increased. And because of the increase in the stability, we are able to improve the product quality and also reduce the energy consumption, improve the energy efficiency of the plant. So in that way, it was a very positive outcome, and both in terms of the soft sensor credibility and the reliability, also in terms of the closed looping and the overall benefit that which we aimed at first place in this combination of the PXP and the soft sensors. And now into the structures, the product structure of overall the layers here in the automation portfolio. So it starts with the advanced sensors, goes through the process control, gas and sampling, and then to the optimization layer. So what we do here is the layers are the same, and we augment and complement these layers with adding a soft sensor that is in closed loop with the PXP to get the improved, enhanced benefits. So this means that we still rely on all the physical sensors, and the soft sensor act as a complementary to the physical sensors and creates value by integrating into the ProcessExpert to have a proactive approach in terms of adapting the target much in advance and kind of improving the performance. So this is how the overall structure in terms of the adding the soft sensor to the PXP looks like. And then we move on to the value and the performance, which is very important in terms of the different layers that we can imagine in the optimization world. First thing, of course, the basic thing, we have a manual combination PID. It is very limited, high variable, and has more scope to improve. And then it comes to standard APC with the model-based control technologies and so on, where we could expect around 2 to 4% of benefits depending on the site. And then we have our strong foundation, that is the ProcessExpert 9.1 with the self-adaptive controller, which can add another 2 to 3% to make it 4 to 7% of improved benefit compared to a standard APC. And now, in combination of this strong optimization engine plus the soft sensor, can add another 1 to 2% to make it a 5 to 9% overall improvement. So these are the steps. So we have to see this in the steps on how we take it through from an standard APC to the next level of superior control technology, and then enhance the performance by adding soft sensor to it to create a better visibility and deeper insights through the AI-based predictions, so that we are trying to fill the gaps that is in existence. So that is the overall narrative that I want to give here, and that brings me to the end of this slide. Thank you very much for listening to me. I'll be happy to answer you guys on anything regarding the strategy of implementation or the soft sensor integration and so on. Thank you very much.
Thank you very much, Dinesh. A really intriguing presentation. There are a few questions that people are asking. One that I'd just like to start with is you opened up with a slide, and you said why are these benefits not being fully realized from the different software, and two of the reasons seemed to be kind of human. It was operator trust and adoption, and it was lack of sustained ownership and governance. And this was something that we talked a bit about at Cemtech in Riyadh. There seems to be a lot of importance on on ownership of these systems once they're installed in the plant. For them to be truly effective, the human element is actually still very important. They're not just plug and play. You have to have people buying into them and knowing how to operate them. How do you approach that challenge? So this is a very crucial thing, because for the success of the APC, the trust and the buy-in from the human on site is very important. So the approach here should be like the APC should bring a lot of transparency. That the operator must feel that he is able to understand what is the action that it is taking and why is that taking, and is able to clearly see those things. So bringing transparency and having a UI that he doesn't feel like it is a black box, that he doesn't feel like he doesn't know what it is doing. So then it brings a buy-in that is able to understand, okay, I know why it is happening. I know why this action is happening. So that level of transparency and trust can really increase the engagement of the operator. And that is what we've been thriving for, like I said, from the previous V8, where we completely changed the application because of the reason that the operator should be able to clearly see what is happening within the APC, if not at the back, if not the technology in the back end. So you should be able to at least visualize and see what is going to happen, what has happened, and why it is happening, and what is going to be the next actions. So the transparency and the trust is what is going to improve it. And we have worked a lot on it, and then we could see that
that could really help bring in the buy-in from the operators.
Okay. So buy-in and onboarding the technology with the right people is really important. A couple of related questions. What is the most important input information required by the system in order to provide the best results? And alongside that, I would like to ask this other question: for advanced automation and control of horizontal ball mills, which process data do you primarily use or prefer? Do your control strategies rely mainly on temperature readings, pressures, power draw, and feeding scales, or do you also integrate additional instrumentation such as vibration sensors or acoustic monitoring to monitor chambers? So just if you could just talk around the sensors, the inputs. Another question is around the Softsensor working principle. So I think there's a few questions that come together there.
Yeah. So we must understand very clearly that the dependency is heavy on our reliable signals, the reliable instrumentations, because if you don't have the reliable instrumentation, and we cannot have a reliable soft sensor at first place. So when I say reliable instrumentation, there are key instruments, key signals that is required, for example, in a kiln process and also in a ball mill process, for example, when you asked. But I think the list, I don't think we can talk about the detailed list of the parameters that is required, because it can be 10, it can be 15, or it can be even more than that. But there are certain critical things, like for example, in a kiln, if you have to have a burning zone temperature, you have to have a kiln inlet oxygen, or if you have to have torque measurements. So these are very crucial, even to understand the calciner temperature and so on. Like in a ball mill, vibration might not be crucial, but the ball mill power and the elevator load, and there are other parameters that could be very crucial here. So the approach is like we will get all the required data, the required data set from a plant, and we'll try to see which resonates or which is more relevant or more key in the prediction. And of course, it is just not, like I said, the whole idea is just not going by the data itself, trying to understand it, does it make sense? Because it must be a crucial data or the instrument or the signal that reflects the process, just not that is something which is having a good relation just because it is a only data driven thing. So we identify such parameters which is more relevant and reflecting, and then we build a model and kind of deploy it and train it. So in that way, the crucial instrumentation is very important for both kiln and the mill. To name it, as I said, in the mill, in the kiln, it is more towards the burning zone conditions, and in the mill, it's on the filling percentages and the kilowatt and the elevator power and so on. So these are very crucial to build the model and to see that relationship and the reliability of it.
Okay, thank you, Dinesh, and thanks to John Klein and Jan Kadlec for those questions. There are some more in the Q&A if you'd like to look at those after the presentation, Dinesh. But for now, that's all we've got time for. Thank you. Thank you very much.
And I would appreciate if somebody wants more, they can also write to me to the email address that you see in the screen.